Kia ora, good morning everybody in my physics classes. Today is Wednesday the 25th of August 2021. Following up from yesterday's video about current, we did this little project here and I said electrons come in groups. Fingers and toes come in groups of 20 cool people. Electrons come in bigger groups called coulombs. And I gave you a wee job to do, and it was to look at measuring current, and I did some things here. Electrons are flowing in a wire, and as they go past a counter called an ammeter, measured in coulombs per second or amps. Now, the thing that I didn't make a big fuss of, which I'm going to hop out of here and just make a point of here, in a wire there are atoms, and in the atoms there is a nucleus and electrons whizzing around the outside. In metals like copper, those electrons aren't held on very tightly and they can jump from atom to atom. And most of the time it's all random and adds up to nothing. But when you shut a switch, you push electrons in one direction and so they jump from atom to atom. If you open a switch, they are still there. So they're affiliated with the atom. They're associated with the atoms. Now the cool thing is, when you push electrons out of one side of a battery, they go around, and in a series circuit, the current is always the same everywhere because the electrons follow the leader. And if I come through here, electron current in series is the same everywhere. And that's really cool to know. In a parallel circuit, that's not the case. And I've got another one here, just like a cooking show. Here's one I made earlier. Is the electron sitting in the copper wires, not doing anything, just bouncing around and on average doing nothing. You put an electric field on there, you give them a shove, push them this way, pull them that way. Now the electrons, the current, the number of amps, the current is split, it's shared out. So we use split here. Current comes in here, 1.8 coulombs per second, come down, 0.9 of them go there and another 0.9 go there, and there can be some more. If I change the strength of this thing here a bit, then we don't get an even split, and we get the current is split, but not evenly. So that's kind of cool. I thought you'd like to know that. So if we come back to here, and we've got ourselves a summary. Current in parallel is split, and the summary is current in parallel is split, and current in series is the same. Thanks, fellas. That'll do for today.